Hi gang, I wanted to get a video out before Friday was over. Happy Friday to you all. This is coming in a little late, but better late than never. So a question on the test that you're going to have in terms of section 4.7 is that it's going to give you like a list of tangent, cotangent, secant, cosecant functions. And it's going to show you 3 graphs. And it's going to ask you to match 3 of the functions to the 3 graphs. So this is 4.7, so if you don't remember how to do this, you may want to go back over it. I showed you how to draw the graphs through doing a modified table. The way the book does it, it's a really nice technique. So I'll just like go over 4.7 if you need, because I've already written these out because these would take me a while to do on camera. But like remember, if you're doing cosecant or secant, those are the parabola looking functions. So cosecant and secant, they look like the parabolas. So when you're trying to match the 3 graphs, if you start by just looking to see if they're sort of like the floating parabolas, you know that's got to be a secant or a cosecant, right? Because those are the ones that have that shape where it's like a parabola up, a parabola down. And then if you have the tangent, unless it's flipped over the x-axis, you know the tangent's going to go uphill, right? And you know that the cotangent is going to come downhill. So the tangent looks a little bit like that cube function. It's got the, I'm drawing this too quick and too sloppy, but you know, the tangent's going uphill, the cotangent's going downhill, unless there's a negative in front and it's reflected over the x-axis. So you could start with just like the basics of knowing what the basic shapes are. I did these nice, I didn't rough sketch them. So if you have the cosecant, if you put a 2 in front of it, when you draw its, we usually, the way the book showed you and I drew for lectures, you have sort of the reciprocal function here, which is the sine, and the sine has an amplitude of 2. So on the sine function, it's a vertical stretch because of the amplitude, which will then push away the cosecant 2 units from the x-axis. Okay. The other parts are the same. It's still the same width, and the parabolas still sit where they would usually sit. But it's the amplitudes pushing them up and down farther. Okay, so then another one, the cotangent, as I was just trying to say there, the cotangent sort of looks like negative x cubed, so it's going downhill. This one is a horizontal stretch, so it's twice as wide as it would usually be, right? It usually goes from 0 to pi, but now it's going from 0 to 2 pi. I wrote the standard cotangent table and then the modified table and the work I did with it. Okay, so you have to sort of have a sense of like what the parent function looks like and you know, where the graph usually falls, because usually this would fall between 0 and pi, but since it's a horizontal stretch, it's twice as large. So secant, we have a secant again, so not only does this being pushed off the x-axis with an amplitude of 2, this has also got a horizontal stretch, right? Because usually the center parabolic shape would fall in between negative pi over 2 and pi over 2, right? It would usually fall in between negative pi over 2 and pi over 2, but now it's falling in between negative pi and pi because of this horizontal stretch. So those 6 graphs, I just sort of drew them out for you. Okay, the cotangent function. So again, that one's the one that is like a negative x squared. It's going downhill. This one is shifted pi over 4 units to the right, so it has this phase shift where it's pushed over, because usually it goes from 0 to pi, but now you'll notice since it's been pushed over, it's going to pi over 4 to 5 pi over 4. Same concept, I just did the tables like you would have seen me do in section 4.7. And then this one is a secant, just with an amplitude shift. So you could see it's doing its standard in between negative pi over 2 and pi over 2. But it usually starts at a 1. The hills and valleys are at a 1 and negative 1, but as you can see, it's got an amplitude change. Okay, gang, so however you think you're going to do that, you will get, like I said, for the test, you'll be given 6 functions, you'll be given 3 graphs, and from the 6 functions, you need to pick which one is represented in the graph. For 4.7, you should go in knowing that cosecant and secant are these parabolic functions. Cotangent comes downhill unless it's reflected. Tangent goes uphill unless it's reflected. So just know basically what the parent function looks like and where it falls so that you can match up the graph. And if you want, like I said, you could just try to draw some for starters just to get get your bearings. Okay, gang, I will send out more videos, but I hope that helped. This is just a really, really quick overview of what you will be expecting. So if you need to go back through the lecture, it's 4.7, and please then look through it. And I've worked out everything in slow detail. All right, gang, I'll catch you then. Bye-bye.